Guys, it's going to be a bit of a marathon today. But just a couple of announcements. This unit is fairly short, so we're in our second to last section of the unit. So I'm planning on finishing the unit Friday, so tomorrow. Review Monday, test Tuesday. All right. So Tuesday will be your test on exponentials and logs. So that means make sure your journal is done. All right. So make sure you copy all that stuff in your journal. Make sure that your Delta Maths and any other assignments get done. If you do the optional work, make sure you get that submitted in Canvas before midnight on the test day. All right. So, especially your journal, guys, because remember, that's a very easy 100 grade, and it's the equivalent of a quiz grade. All right. So, make sure that you get that done. All right. So, today we are finally getting out of exponential. Oh, crud. It's like I build it up and then it just, nope. All right. So, today we are getting out of exponentials and into logarithms. Now, logarithms still connect to exponentials, but it's a completely different type of function. So, you remember on that worksheet from yesterday, you probably saw where it said log of blah, 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 like the actual word log. That's a logarithmic function. All right. And they relate to exponential functions because they're actually exponential functions inverse. So, if you had to take the inverse of an exponential function, that would be a logarithmic function. So we're going to first look at how exponentials and logarithms connect, and then just some general things about converting between the two. And of course, the graphing of logarithms. All right. So, like I said, exponential functions are important in mathematics, and their inverses that reverse their action are important themselves, and that is logarithms. So logarithms are the inverses of exponentials. So remember in Unit 1 when we did inverses? And what was the main thing with inverses? Like, what was the one thing that I told you had to remember when it came to anything inverse? You have to do what? Not the x-intercept. What'd you say? Oh, that's functions. That's part of it. But what was the biggest thing with inverses? How do we know if it was an inverse? Right, you switch the x and the y's. All right. So if it was an inverse function, then yeah, the x's could repeat. So they went ahead and graphed this exponential for us. They gave us the table and they went ahead and graphed it on the graph. Now, is this a one-to-one function? So we talked about this back in Unit 1. Does anyone remember what makes a one-to-one function? So Alexa already said the first part, which is no repeating x's, but what's the other part? Say it one more time. It passes the vertical line test and you said the horizontal line test too? That's correct. And then what else? There's one last thing. Someone besides Camden, someone different. So, x's can't repeat. Has to pass vertical line and horizontal line test. And what's the last one? It connects to the horizontal line test. All right, Camden, go. No repeating y's. All right. So, no repeating x's, no repeating y's. That's what one-to-one means. So, do you think this table represents a one-to-one function? Yes or no? It's on your packet, guys. So don't look at it too hard. Yes. Why? Right. So yes, because x values and y values Do not repeat. All right. Now, we talked about this when we talked about inverse functions. If a function is a one-to-one function, what does that say about its inverse? Say one more time. Think quickly. Come on. Right. It's also going to be one-to-one or specifically a function. All right. So if it's a one-to-one function, the inverse is also going to be a function. Inverse will be a function. So since we're all right, so now we're trying to find the inverse of the table that we were already given. So how do I write the table out for that? What do I have to do? Just switch the x and y's. So up here, I'm just going to flip these two rows. So the x's will now be 1/8, 1/4, 1/2, 1, 2, 4, 8. And the y's will now be -3, -2, -1, 0, 1, 2, 3. So all we did was switch the x and y's of the top table. All we did. Now we're going to plot these points on the graph next to it. So we're going to graph it on the same graph as the exponential function. So I have 1/8, -3, and just get as close as you can. Doesn't have to be perfect. 1/4, -2, 1/2, 1, 1, 0, 2, 1, 4, 2, and 8, 3. So our function will look something like this. And this would be the inverse of f of x. So we don't know what that function is yet. We just know that it's the inverse of 2 raised to the x power. And then just to make a note, remember that the inverse function and the original function, they're technically a reflection of each other over the line y equals x. And it's already stated right here. So, for example, on your Unit 1 test, there was a question that you had to graph the inverse. Some of you got the function graph correctly, but the inverse, you did a reflection over the x-axis. It's over the line y equals x. All right. So it's not just the signs that change. In fact, the signs don't typically change. You just have to flip the x and y values. All right. So if we were going to find the inverse algebraically, what would be our first step? So remember when we were finding inverse functions algebraically, what was always the first thing that we did? We changed the x to the y. So if we originally started with y equals 2 to the x power, to find the inverse, all we would do is flip the place of the x and the y. So this would be x is equal to 2y, to the y power. Now, we're going to stop there for right now because we don't know how to evaluate that yet or solve for y yet. All right? Because now, this is where the logarithms come in. All right? So this is a brand new function. You've never seen it before in any class. The first time you ever see a log function is in Math 3. All right? So when we're talking about logarithmic functions, a logarithmic function, which is typically as y equals log b of x, that's how you say it, is given the inverse of y equals b to the x power. Now, technically, our inverse of y equals 2x is y equals log 2 of x. So that's our inverse. Now, I'm going to explain in a second how you actually find that. But if we write an equivalent exponential equation for a logarithm, that's the same thing as y equals log b of x, which is the same thing as b to the y power equals x. So essentially, it's what we started with up here in the blue with our 2 to the y power, but it's in a logarithm form. Now, there's a very easy way to do this. So, with logarithms, the method loggy froggy is going to be your friend. And yes, I said froggy. All right. So, what loggy froggy is that it is the method to convert between logs and exponentials. Oops. Now, I'm going to show you how loggy froggy works with our x equals 2y. All right, so they already told us that inverse is log 2 of x. All right. Now, couple of things to note with a log function before I even get into that. With a log function, so we know that with an exponential function, b is your base. Whatever's in your exponent is your exponent. And whatever it's equal to is known as the argument. Well, it's the exact same thing with log functions, but they're in different spots. So your base is now that tiny number next to the log. So this is your base. Your argument is what goes next to the log. And technically, what it's equal to is the same as the exponent of the exponential. And again, don't worry about like the placement right now because when we do loggy froggy, it's really obvious where it is or how to write it. So let's do some loggy froggy with x equals 2y. So first thing I'm going to do, just because it makes your life a lot easier, is write it so that it looks like the exponential comes first and then it's equal to whatever. Now, when it comes to loggy froggy, start at the base. All right. So I'm going to draw a dot right under the base, which is 2. Now, I call this your hits. So you need to hit every piece of this function. All right, but there's a specific order. So we always swing to the right, and then boom, we hit the X. Boom, we hit the equal sign. And boom, we hit the Y. And if you look, this is why it's called Logus Frogus. Looks like a little frog. All right. That's why we call it Logus Frog. Because it literally looks like a frog when you draw it. So what this is that what I just did is telling you the order that you're going to write it in your log form. All right. So the first thing you would write, you always start with the log part. So you always start with that in log form. The next thing you would write is the little number next to the log, which is your base. So in this case, that's where I started my loggy froggy. So this is base 2. Then I go to whatever I hit next, which was the x. That goes in the parentheses next to the log. Then I write my equal sign. And it's equal to whatever's in my exponent, which is the last thing I hit, which is y. So this would be the inverse function of y equals to the x power. So that's how, if I asked you to find the inverse of an exponential, that's how you would find it. You change the x and the y, then do loggy froggy to get the log function. So biggest thing you need to do is you need to memorize how the typical log function is set up. So log b of some number is equal to some number, or some value is equal to some value. All right, that's what you need to remember. It also works in reverse. All right, so let's say that I started with log 3 of x is equal to 2. All right, same thing as we did with exponentials. You always start at the base, which is that little number, and you're going to swing to the right. So I'm going to hit the 2, hit the equal sign, and then hit the x. So you start at the base and you swing it to the right. All right. And there's my little frog. So if I write it in the order of the exponential, so b raised to some power is equal to some value, this would be 3 squared is equal to x. And all I did was write it in the order of my frog. So you got to remember the basic orders. So you got to remember at least this part. But after that, Loggy Froggy tells you exactly how to write it from left to right for each piece. Does that make sense? All right. So let's use that to evaluate some logs. Now, evaluating logs you can do without your calculator. So one way you can do it is that it's almost like the opposite of what we were doing yesterday with exponentials. All right, when we were doing the same base method. All right, so when we were using our power chart, I would tell you, okay, which base would give you both these two numbers. Well, now, if we know what the base is, which is that little number, we're finding what number gives us, when using that base, gives us this number. All right. Now, that probably doesn't make a lot of sense. I prefer doing it in terms of loggy froggy because then if you turn it to an exponential, it's easier to see. All right. So I usually set this equal to x. I then do loggy froggy. So I start at the base, which is the 2, swing to the right to the x, hit the equal sign, hit the 8. So if I write it in order, I have 2, which is my base, raised to the x power is equal to 8. Now, we don't really need to do like a same base type deal because we can kind of eyeball this. 2 raised to what power is 8? So what power of 2 will give us 8? Not 4. That'd be 2 times 4. 3. So 2 cubed is the same thing as 8. So 2 cubed is equal to 8. So that means x is equal to 3. All right. We can do the same thing with letter B. So I set it equal to x and then do loggy froggy. So start at the 4, swing to the x, swing to the equal sign, and finally hit the 16. And then I write it in order. So I know my base is 4, so then it has to be raised to the x power and be equal to 16. So 4 raised to what power is 16? 2. So 4 squared is equal to 16. So x has to be equal to 2. This starting to make sense? Pretty straightforward, right? As long as you're a master of logy, froggy, the stuff that you need to do between logs and exponentials are pretty straightforward. All right, now, without doing logy, froggy, let's see if we can evaluate this without it. So, think about this carefully. The base is 5, and some power raised to, so 5 raised to some power is going to give us 625. What power is that? So we're raising to an exponent, not multiplying. 4. So 5 to the 4th power is equal to 625. Now, if we did logy froggy, so set it equal to x and do our swing around, we get 5 to the x power is equal to 625. So x is equal to 4. All right. So again, you can eyeball it, but if eyeballing it confuses you, do logy froggy, and then it's easier to see it when it's an exponential. All right, one more in this section. So letter G. Actually, no, I lied. Not G. Let's do H. So set it equal to x. Start at the base, which is that little baby 3. Then I swing to the right, hit the x, hit the equal sign, hit the 5th root of 9. So this will be 3 to the x power is equal to the 5th root of 9. Now, this one's a little bit complicated. This one you may have to, do some change base. All right. So, first off, let's change what's under that radical first. So, what base of 3 gives us 9? So, 3 raised to what power gives us 9? 2. So, I'm going to change this to 3 to the x is equal to the 5th root of 3 squared. Now, remember, we can convert a root to a fraction. All right? Meaning, if we take the root number that's listed, that little number here, that's what our denominator is. Our numerator is the exponent that's underneath the radical. So this would be exactly the same as 3x is equal to 3 raised to the 2 over 5. All right. So remember, once we get the same base, what can we do? So review from yesterday. If we have the same bases now, what can we do? Get rid of them and then bring down our exponent. So x is equal to 2/5. So that one would have been one where you couldn't have just eyeballed it. You may have had to do some same base methods. Now, in your calculator, you can also put logs in your calculator. But you got to be careful because, and I'll show you in just a second, but as soon as this loads, there is a log key on your calculator. However, that log key does not allow you to put in the base. So this log key right here, if you click that, And we'll talk about this tomorrow, but this will give you log base 10 automatically, and you can't change it. So you want to put a log in to evaluate it. What you need to do is you need to hit math, then scroll down, or no, it's under number. Go to I've done this before. Where is it? There it is. Okay. So you hit math and then you scroll down until you see this. So log of some base. All right. If you click enter, it'll now let you input the base number. So let's say if I did it for letter F. All right. I can put in 2, and then in the parentheses, I can do 1 divided by 16, which is the same thing as 1 over 16. Then if I hit enter, my answer is -4, which if we did loggy froggy, we would have gotten the same answer. All right. So again, if you ever need to put a log in your calculator and it has a base, like an actual base, don't use the log key, hit math, and then scroll down till you see log of some base. All right. Okay, sleepy babies. Last little bit, and then we'll go on break. So hold in there. We're almost done. Okay, at least for this part. So what's critically important to understand is that logarithms give exponents as their outputs. All right. So that's why when we had log base 2 of 16, it was equal to 4. That's technically what you would raise 2 to get 16. Now, we'll be working multiple lessons with logarithms, and having that basic understanding is really, really important. Now, we're going to skip exercise 3 just because it's asking for the y-intercept. So literally, that's just a matter of putting this in Desmos and getting an answer. All right. By the way, in Desmos, if you wanted to put a logarithm in, you just hit the function key on your keyboard and just scroll down until you see log of the number. All right, you'll see it in there. Now, exercise 4, they're asking what 2 integers does log 3 of 40 lie? So we're just going to put that in our calculator and see what we get. So if I hit math, scroll all the way down until I see log base, hit enter. I have 3 as the base, and my argument's 40. So 3.357-ish. So this will be between 3 and 4. All right, last thing I got to mention for logs, and then we'll go on break. This is the very last thing. At least, again, for this section. We got to come back and do more notes. But anytime you use calculators with logarithms, I already touched on this, but typically you'll see log base 10 of x. This is known as the common log. It's a log that's commonly used a whole lot, all right? And it's written in terms of base 10. So that's why I said don't just hit the log key, because that gives you the common log, which is log base 10. So you need to remember, if you just see log and there's no little number for the base, it's the exact same thing as log base 10. Now, we're going to use our calculator to just do the first one, just so you can see what it looks like. So, log of 100. This is the one where I'll actually hit the logarithm key. So I'll hit the log key and then type in 100. So notice how there's no base listed here. There's no little number. That's because there's an unspoken 10 there. All right. So hit enter. The answer is 2. There's one other type of log I want to mention because it'll be thrown at you a little bit. This one's called the natural log. And all the natural log is that it's a log with a base of E. So remember yesterday when or 2 days ago when we talked about the number E? Remember that? The number E, it's a number that's a letter. Yep. So you'll see that as ln of x. So if you see ln of some number or of a variable, it is a log, but it's called the natural log. All right, it's log with a base of E. So it has a base of E. And I mean the number E, not the letter E. So you really just need to remember this part. All right, any questions so far? All right, so we're going to go ahead and take our 5-minute break because I got a lot of sleepy babies. I need you back in this classroom by 10:05. Oh, yeah, my setup. Yeah.
Yeah. Mostly about my Yeah. Originally, he said, I spit. He said, he said, can whatever. After he can. You got 35 by 2. So, I eat everything. I got a freaking question. I did. Yeah, I did.
All right, guys, it's 10:05, so let's get back to the grind. All right, so take out that worksheet that you got yesterday. I just want to do a couple more practice examples on Loggy Froggy, just to make sure you guys got it. All right. So it's that worksheet that you grabbed yesterday, the one that says logarithmic form on top. So you guys are going to walk me through converting these to exponentials with Loggy Froggy. All right. So where do I start my Loggy Froggy? At the 1/9. What's the next value that I hit? 0. Then equals. Then 1. So when I write it, what comes first? 1/9. Then where's the 0 go? The exponent. Then right. So again, guys, hit the base first and then swing to the right. Now, if it's written that the log is on the right side, rewrite it so it's on the left, because it's easier when it's on the left. All right, same thing with the exponential. If the exponent is on the right side, rewrite it so it's on the left. Makes your life so much easier. All right, so let's try number 4. Where do I start? I put a what? A 10. So remember, this is log of a base 10. So there's an unspoken 10 there. So don't get confused if you don't see the base. You just got to put a little 10. So we start at the 10. Where do I go next? Someone besides my front people. The 2. Equal sign. 100. So, right? So how would I draw it? Or write it out? 10 comes first. Where's the 2? Exponent. Equals 100. Does everyone understand how to go from a log to an exponential? All right, let's do about 2 examples with going from exponential to log. So remember, it's the same process. You still start with the base and you swing around to the right. So let's do number 9. So where am I starting loggy froggy at? The 19, that's the base. Where do I hit next? 361, then equal sign, then the exponent. So how do I write it? I need to write log first, then the 19 as a little number. What goes in the parentheses? 361, and it's equal to 2. And that's all you got to do. All right, one more. Let's try number 11. What do I hit first? The A, that's my base. What's next? B, then equals, then 3. So how do I write it? Log A of B is equal to 3. So guys, if this was on the test and I asked you to convert between a log and an exponential, could you do it? Yes. 10? Sure. All right, so number 10. Okay, don't let the fraction throw you. The fraction's your base. All right. So we're starting with the 9 over 5. So our base will actually write 9 over 5. What do I hit next? The y. Then the equal, then the what? X. So this will be log of 9/5 y is equal to x. So if your base is a fraction, that just means your base is a fraction. All right. There's not like an extra number thrown in there or anything. All right. Any questions on converting? All right. So now let's look at the graphing of logarithms. So turn to page in your packet. Turn to page 19. All right, so this is technically the other part of 2.1. So do you guys remember when I said that 2.1 is like, we're going to put a pin in it and come back to it when we did it with exponentials? Now we're coming back to it. Okay, we're taking the pin out, coming back to it. So we already know if you have log base 3 of x, its inverse is y equals 3 to the x power. All right. So let's fill in the table for y equals 3 to the x. So think about it. Your x values are your exponents. That's what you're raising 3 to. So let's just do this by hand. What is 3 raised to the negative 2 power? It's on your power chart. 1/9. It's the same thing as 1 over 3 squared. What about 3 to the negative 1 power? 1/3. It's the same thing as 1 over 3 to the first. 3 to the 0 power? 1. Anything raised to the 0 power is 1. 3 to the first power? 3. And then 3 squared? 9. So let's go ahead and graph that. So I have -2, 1/9, -1, 1/3, and it's not going to be perfect. 0, 1, 1, 3, and 2, 3, 6, 9. So this is what my graph's going to look like. Now, remember, when we talked about exponentials, all exponential graphs have a what? They have an asymptote. What type of asymptote, though? It's a horizontal. So, can anyone tell me what an asymptote is? It's the line that the graph doesn't cross. So, what do you think my line that the graph doesn't cross here is? the x-axis. So the x-axis is where my horizontal asymptote is. What is that in terms of y? So y equals what number? Y equals, what type of y values would be at the x-axis? So if you were plotting a point and that point was on the x-axis, it has a y value of what? 0. So y equals 0, that's our horizontal asymptote. All right. Now we're going to graph our log function. And remember, our log function, since it's the inverse of 3 to the x power, we already pretty much have our table. What do we need to do, though? Flip the x and the y. So since log 3 of x is the inverse of 3 to the x power, all we got to do is switch the 2 rows of our previous table. So this will be 1/9, 1/3, 1, 3, 9. This will be -2, -1, 0, 1, 2. So I'm going to take a minute and graph it. Now, note, the horizontal asymptote does not apply to the log function. So it's going to cross the horizontal asymptote. All right. The horizontal asymptote only applies to the exponential. So I have 1/9, -2, 1/3, 1, 1, 0, 1, or 3, 1, and then 9, 2. So my log graph will look like this. Now, let me tell you something. Exponentials and log graphs are inverses in every sense. So that also includes their asymptote. So think about this carefully. If an exponential graph always has a horizontal asymptote, what type of asymptote do you think a logarithmic graph will have? A vertical. All right. So a logarithmic graph always has a vertical asymptote. So it's a vertical line that our graph can't cross. Now, we write that in terms of x equals some number. So if we switch x and y, technically, that also applies to the asymptote. So if we had y equals 0 originally, what do you think x is going to equal for our vertical asymptote? If we flip them. 0. Still going to be 0. All right. So if we have a function and then it's inverse, so one's an exponential, one's a logarithm, the asymptote is technically the same number. You just switch the x to y. All right, so one would be y equals that number, one would be x equals that number. So just remember, logarithms are vertical asymptotes, exponentials are horizontal asymptotes. All right, so if I were to draw the vertical asymptote, that's my y-axis. So it'd be right here. And if you notice, if you look at the graph of my logarithm, it never crosses this vertical line. All right. It gets like really, really close to it. And if we looked at a decimal version of it, it'll get like right up against the y-axis. But just like with the horizontal asymptote, it won't cross it. Any questions on that? So that then plays into our domain. So we talked about this, I think it was last week. What's always the domain of an exponential function? All real numbers. So negative infinity to positive infinity. That's all real numbers. What would the range be of the exponential function? What would our lowest y value be? 0, because that's our asymptote. Do we do a parenthesis or a bracket since it's an S? Right, parenthesis, because it's our asymptote, and it goes to where? It goes on forever, right? So it goes to infinity. Now, guess what? Domain is your x values, y is your y values. So, all you gotta do for its inverse is flip them. So, without even having to look at our log graph, my domain is going to be from 0 to infinity, which is true because my lowest set of x values are at x equals 0, but it never crosses it. So we continue on and it goes on forever to the right. And my y values are now all real numbers, so from negative infinity to a positive infinity. And that's true because if you look at our graph, there's an arrow, which means it goes down forever. There's an arrow, which means it goes up forever. It's very slowly. All right. Does that make sense? So that's the beautiful thing about logarithms and exponentials, especially if you're trying to relate the two together. You have the exponential and its inverse logarithm, everything's just flip-flopped. All right, so if you can find the domain and range for an exponential, its corresponding logarithm is just the opposite. All right. Okay. So that's all I wanted to cover in your packet. But now let's get your journal. So your journal, and I want your 2.1 entry. So that trifold that we did with the two graphs on it, the two tables, we're going to finish it now. And we're just going to basically restate what we already talked about. So it's your journal that looks like this. So you should have stuff already inputted for exponentials. Now we're going to do the logarithm side of it. So it should be that first entry for your Unit 2 journal. Yes. Say that one more time. I'm not going to do a goal sheet this time around. All right. So logarithmic functions. We can do this fairly quickly. With a logarithmic function. Is everyone there? Did they find it? It's the trifold, so it's the one with the two flaps that we've done before for Unit 2. So with a logarithm, this is your general form. And remember, just to note, this would be your exponent technically. Your b is always your base. And then the value next to the log itself is known as your argument. Now, there's a lot of laws when it comes to logarithms, but we're not really going to get into that in this class. If you take Math 4, you may see them. Yes. Yeah. Now, this would be your graph of the log. So it looks like that. This graph is technically doing what? Increasing or decreasing? It's increasing. It's technically going up. Even though it kind of staggers about right here, it's still going to keep going up, just really, really slowly. So it's like the opposite of an exponential. Instead of starting slowly and then getting big really, really quickly, it starts quickly and then slows down. All right. Our vertical asymptote would be right here at x equals 0. So this is our vertical asymptote. Now, Note, a logarithm always has a vertical asymptote. And remember, you write that as x is equal to some number. So if I ever ask you what is the vertical asymptote of this graph, you need to say x equals some number. Do not just give me a number. All right? If you just give me a number, it's counted wrong. Because you have to write it as an equation of a line. A number is not an equation of a line. All right? Now, let's fill in our table very, very quickly on the inside. It's very quick. It's basically all the stuff we just discussed. So, log 2 of x is the inverse of 2 of x. So we technically already have our table filled out. We just have to switch the x and the y values. So what are my x values for my logarithm? So guys, what are my x values for my logarithm? 1/8, then 4th, half, 1, 2, 4, 8. And we're going to stop there. If you wanted to go further, the next one would be 16. So our y values will now be the x values of 2 to the x power. So this will be -3, -2, -1, 0, 1, 2, 3, and this one will be 4. So if I graph this graph, I have 1/8, -2, 1/4, or no, not -2, -3, 1/4, -2, 1/2, 1, -1, 1, 0, 2, 1, 4, 2, 8, 3, and we're not going to graph that last point 16, 4 because it goes off the graph. So if we were to draw it, it would look like this. So this would be y equals log 2 of x. Now remember, it has that horizontal asymptote. Ah, crud. Now remember, it has that vertical asymptote at the y-axis. That's not always true for every logarithm, but in this case, it is. So this is x equals 0. That's our vertical asymptote. Now, we already said what our domain would be. Our domain would be the opposite of our range of our. We would just flip the domain and range of its inverse, so the 2 to the x power. So since the domain here is negative infinity to positive infinity, but the range is 0 to infinity, that means the domain of our logarithm is 0 to infinity. And our range is negative infinity to positive infinity. So all real numbers. So if we wanted to make that note down here about how you can find the domain and range for log graphs, all you would have to do is switch the domain and range. So for log graphs, the range is always all real numbers. whereas the domain depends on where the vertical asymptote is. Does that make sense? Yes, no, maybe. All right, so that is it for today. So it wasn't too bad in terms of notes. We still got about 30 minutes left. All right, but I kind of hit the ground running with that. So if there's any part that you're confused on, please talk to me about it because I know I did that fairly fast today. All right, but the content wasn't too bad, so that's why I did it quickly, a little bit faster. All right, so what you need to be doing for the rest of class, there are 2 quizzes assigned to you, like in quizzes, like the application quizzes. All right, there's one for 2.3, there's one for 2.1. All right, so I would go ahead and get those done. They're just assigned to you, so I don't have like a code or anything. They're just assigned to you. All right, so that's what you guys need to be doing now. You got a solid 30 minutes. If you finish early, so if you finish both of them, you can work on Delta Mats or the optional work, whatever you want to do, as long as you're working. Now, the quizzes is completely independent, so you cannot work together on them. You do get 2 attempts on them, though. So if you don't like your score on your first try, take it again. And remember, quizzes are due by test day, so make sure you get them done now. Yes. No, they got it on Friday of last week. Is it already pasted in your journal?